how nervous you are, enjoy this session, enjoy this day, because only when you are not nervous, only when you are calm and composed can you crack the examination. And for sure you will ace the examination only in the right frame of mind. So watch the session peacefully. Do not be nervous. Do not be tense. It's all going to go well. You have been with me in all the marathon sessions and you have studied after that. So for sure you're going to ace the examination. So today's session is all about the high weightage, important questions from every chapter, and for the Term 1 CBSE 12th board examination. And I'm Shreyas, your physics master teacher, your captain. You call me Capto. That's what makes my day. Thank you everyone for being here and welcome aboard. And yes, you can get in touch with me on my Instagram handle Shreyas_Vedantu. Hello Rohan, hello Priyasa, hello Raj, hello Anusmita, Rajastri. Thank you Harita for all the hearts. Welcome Nishwa, welcome Dominic, welcome aboard everyone. I can see all the love. I can see all my lovely warriors right on this channel. Now, before we go ahead, I want to tell you one very important thing. Have you noticed my class timings? Have you noticed the timings of the marathon session? Have you realized why I have kept it at this time? Why not in the evening? Why not early morning? Can you guys put it up in the comment section? Can you guys just put it? Why do you think I have conducted these sessions at this particular time? Harshita has realized it. Hello Aditya. Hello Shalini. Hello Rizwang Sheikh. Welcome. Not just for the revision. Yes Riji, correcto. Exam time. Exam time. Your mindset is now framed. It's set for the last 3 days. Even today, your mind is now set. Yes, 11 o'clock. That's it. Exam time. So during this time between 10:30 to 2 o'clock, your mind is going to be very active. You're not going to feel sleepy because you have stayed here. So thank you very much for that. And also thank you for smashing the like button. And also thank you for subscribing to VEnthuse. VEnthuse is a dedicated English medium channel for all the students who want to prepare not just for CBSE but also for JEE, KVPY, BITSAT, VIT EEE, SRM JEE, you name it. Your one-stop solution for all the competitive examinations for your engineering entrances. So welcome aboard. This is Capto Shreyas. And yes, if you have not yet smashed it, go ahead, smash that like button right now. Let's begin the session. Are you guys ready? How's the Josh? Please don't tell me you are nervous. No, nobody is nervous because you are going to attend this class and you're going to crack it and you're going to come out tomorrow very happy. The duration of the class will be at least 2 hours. At least 2 hours. Okay. Yes, Rohan, I had my breakfast. Akib says, hi, very good. So let's begin with the first chapter, electric charges and fields. Questions and questions only, like I promised you. No theory, no formulas. All right, just questions just for you. All right, so let's begin. Very good, Musik. You finished watching yesterday's session. Yep, very good. High five. Let's begin. First question coming up on your screen. I hope you have your rough work, pens ready and your brains are open to grasp everything that I'm going to say. There is an attractive force 9 Newton which acts between two metallic spheres 5 coulomb and -5 coulombs at some distance. This is a warm-up question. Okay, this is a warm-up question. This is very straightforward. You should be able to do this. Come on. Now they are allowed to touch each other and they are placed at the same position. What will be the new force between them? Okay. Niveta saying D, Ishwari saying A, Jagan saying D, Khushi saying B. Well, we have variety of options. Okay, D. Okay, majority of you are going with the D and looks like, okay, I'll give you more 5 seconds. 5, 4, 3, 2, 1. All right, just 1 second, guys. Okay, perfect. Looks like you guys are correct. The reason for that was very easy because you had read the question carefully. Plus 5 coulombs, -5 coulomb. So when you touch them, plus 5 will neutralize -5. This will become 0. This will become 0. So now when you again put it back at the same points, obviously there will be no force between them because they are neutralized. That's it. That's the answer. 0. Next question. Okay, now let's go ahead now that you're warmed up. So three charges 4q, q and q, small q and capital Q, different, okay, are placed on the x-axis 0, 0, 0.50, 1, 0. What should be the value of q in order to make the net force on small q? This one, 0. All of them are mentioned. So guys, think about it. What is going to be the answer? Some of you have already started posting the answers. C, A, B, C, A, B. Okay. Some of you are also saying D. Guys, finalize. Think about it carefully. Draw it. Plus 4q. Okay. Is at 0, 0. This is your x-axis. Okay. This is your x-axis. This is your origin. Then 0.5. You have capital Q. And so this is at 0.5. And at 1, you have that another small q. This is at 1. So obviously, if you want the net force on this charge to be 0, that means this plus 4q will be applying a repelling force over here. This will be the force by the 4q charge, and there will be an attractive force by this q charge. That's the only way it can neutralize. So it's very obvious this charge must be negative. It must be negative. There is no option in that. So just equate them. So magnitude wise, the force of q should be equal to the force of that 4 small q charge. That's it. Just do the math and you'll get the answer. So this will be k into q into small q divided by distance is 0.5 square, and this one over here will be, this distance is 1. The charges are 4q and small q. So k into 4q into small q divided by distance square. So many things have just got cancelled, like k, small q, small q. So q will be nothing but 4 small q into 0.5 square, which is nothing but 0.25, which is nothing but q. So this is all magnitude wise, understand, this is all magnitude wise, but sign wise it will be negative. So hence option A will be correct. I just mentioned it is negative. Whatever we found over here was modulus, the magnitude. Everybody clear? Yes, everybody clear about this? Very good, very good. Let's move ahead with the next question, which is going to come up on your screen. Just 1 second, guys. I need to just arrange my light. Okay, I think now it should be fine. All right, cool. Let's get moving to the next one. Here is the next question coming up on your screen. Let me just change the lighting little bit. Here is the next question. A charge q is divided into 2 parts. The question is, what do you think should be the ratio so that the force between them is maximum? What do you think should be the ratio between the charges so that the force between them is maximum? Okay, just check this out. All right, I'm just going to change the settings. Just give me a second. Okay, now I think it is fine. Now I think it should be fine. Just check this out. Okay, all right. Okay, Sarath, now I think it should be fine. Anirudh, the session will be at least for 2 hours. Okay, fine, cool. Think about it. What should be the ratio of the charges? All right, so charge q is divided into 2 parts. So if you take this q and divide it into q, and the remaining will be q minus q, if the force between them will be k, q into q minus q divided by r square. If you want to make this maximum, think of it this way. I'll give a simple problem. Let's say this charge is 10. How can you divide it? You can divide it as 1, 9, 2, 8, right? 3 into 7, and then also like 4, 6, 5, 5. Okay, these are the different possibilities in which you can divide it. You can also divide it as 6, 4, and so on and so forth. Now, the idea is, if you want to make the force maximum, you want their product to be maximum. Their sum is constant. Can you see? The sum is constant. What you want is basically the product to be maximum. Check it out. 1 into 9 is 9. 2 into 8 is 16. But if you do 5 into 5, you get 25. Everything else, 4 6 are 24, 7 3s are 21. Only when the values are equal is the product maximum. Do you see that? Exactly. So same is applicable for any numbers. You take any number, you want to divide it into 2 parts such that their product is maximum, it has to be equal. So hence the ratio should be 1:1. So the ratio should be 1:1. I think this is clear now. Everybody understood this particular property? Very good. Excellent, my warriors. Option A, not half. Read the question carefully. Acha, the Q. Oh, sorry. I think this option shouldn't have been A. Oh, my bad. My bad. Guys, I'm so sorry. This Q is divided into two parts. So if capital Q, if it was 10, then the value of small q should be 5. So this Q by Q should have been 2 by 1. Okay, it should have been 2 by 1. Okay, that option is missing out here. Yes, I think this was wrong. Just ignore this. Okay, just ignore this. Okay, it should have been 2:1 because capital Q charge is the bigger one, small q is the smaller one. Okay, so I thought it was just Q1 by Q1 is to that charge distribution will be 1:1. So as compared to the initial charge, it has to be 2:1. Okay, okay, fine. So just ignore those options. I'll just get it corrected when the PDF is made. Okay, so don't worry, you will get the correct PDF later on. Yes, Soumya, I'm going to get the PDF as well. Sakshi, it's not about being the closest. The idea is that if it is wrong, it is wrong. Okay, so you have to just ignore it, and don't worry. If you get such a question, then you will get the bonus also. Don't worry. All right. So moving on. Charges Q are each placed at the two opposite corners of a square. Charge small q is also placed at the other two corners. Find the relation between Q and capital Q when the net force on capital Q is 0. Let's see. If the question is minimum, then understand you don't even have to divide it. Don't put any charge over there. You just don't divide it. So if you have one charge, there will be no force. Force will be 0. That's it. That's the answer. Okay, let's get going. Some of you are saying D option. Okay. Come on, think. Okay. Bhadra, the last session PDF will be uploaded in the description box, probably within a few hours, not more than few hours, just 1 or 2 hours. Okay, don't worry about it. Yeah, great. Some of you are saying D, some of you are saying B also. Some of you said B. Be careful. Charge Q is placed at the two corners. So this is plus Q and this is also plus Q. This is one corner, this is other corner. The other corners has Q and this is also Q. Find the relation between them so that the net force on, let's say plus Q is 0. Now this plus Q and this plus Q will obviously repel each other. Okay, they will obviously repel each other. What will be the repulsive force? So for that, think what will be the distance between them? Guys, this side length is, let's say, A. This side length is also A. So obviously this is root 2A. So this force will be nothing but KQQ divided by root 2A whole square. Correct? This will be the repulsive force. But you want the net force to be 0. That means this force should be cancelled by another force. Which other force will cancel this? I think I know what will happen. This Q and this Q, if they are negative, just imagine if this is negative and this is also negative, they will pull it here as well as here. What will this force or this force be? The force between these two charges. Think about it. This force will be nothing but KQQ divided by A square. So if this is KQQ by A square, this is also KQQ by A square, then what will this force be? Think about it. What will this force over here be? It is this square plus this square under root. If two forces are equal, if this is F, what will be the resultant? It will be F root 2. Everybody agrees to this? How did we arrive at this? Pythagoras theorem. Yep, F square plus F square is 2F square. Root of that is root 2F. Correct? So what will be this particular force? This will be root 2 times KQQ divided by A square. Now since the net force is 0, hence this force must be equal to this force. They both must be equal and opposite. But just that, you have to make sure that the signs are opposite. That will put it in the end. So negative options only, either this or this. This is ruled out. Oh, sorry. This or this. This is obviously ruled out because of the positive charge. Fair enough. Just equate them and see what happens. KK gets cancelled. One of the capital Q gets cancelled. A square also will get cancelled. So you will have root 2. You will also have that small q over here is equal to, from there, Q divided by root 2 square is nothing but 2. So capital Q will be nothing but 2 root 2 Q. But this is magnitude wise, 2 root 2 Q. So that's what you are going to get. Just check this out. Okay. So find the relationship between Q and Q. Just 1 second. Have we inverted it or something? Yep. Just check this out. Yeah. So 1 second. One of the Q. All right. So find the relation between Q and Q so that the net force on capital Q is 0. Yes, I think there is again a symbol mismatch. There is a symbol mismatch right over there. Yep, this Q should have been here and this Q should have been here. Yes. So just you just have to interchange the symbols. I think there is a printing mistake over there. Yep. Okay, cool. So otherwise everything is fine. Okay, so I think there was a printing mistake. Don't worry about it. All right, let's get moving. But I hope you understood the concept. These kind of questions are very popular. Questions on triangle, questions on square. These are very, very popular questions. Okay, chalo. Let's get going to the next one. If an electron has an initial velocity in certain direction different from that of an electric field, the path of the electron is how much? Is it a straight line? Is it a circle? Is it an ellipse? Or is it a parabola? Yep. Okay, chalo. Let's see if you can do this question. So the electron has some velocity in a direction which is different from that of the electric field. So for example, this is the direction of the electric field. The motion of that electron is in some other direction. So if that happens, if you give the velocity in some other direction, understand the motion is going to be a curved line. And the moment it is a curved line, it will be a parabola. Why will it not be ellipse? Why will it not be a circle? Why will it not be a straight line? The answer is simple. The acceleration will be constant. And we all know if you throw anything like a mass under gravity, then the path which it takes is a parabolic path. It's a parabolic path. So even this electron, which is accelerated not because of gravity, but because of electric force, that will also take a parabolic path. Remember that. If let's say, for example, this line was not mentioned, direction is different, but let's say this was mentioned, same direction was mentioned. If same direction was mentioned, then what will you do? Yeah, if same direction was mentioned, then what will you do? Think about it. Then, if the direction was same, then the answer will be straight line. Helix is in case of magnetism. Be careful. Let's say, if it was mentioned that the force is always perpendicular to the motion. Let's say the force is always perpendicular to the motion. This is mentioned. Then what will be the answer? Think about it. Yeah, VJ Gamer, not entirely. Okay, don't worry about it. Then it will be a circle. Correct. And yes, when will it be an ellipse? When will it be an ellipse? The answer will be an ellipse if your charge is thrown like a satellite. Yeah, you throw the charge like a satellite around some another charge. Then it will go in an elliptical part. Okay, so if it is thrown at some angle or you throw it with some random speed around any other charge, then it will basically do an elliptical orbit. Obviously, the charges have to be opposite in sign. If one is positive, one is negative. Okay, that's how it will be. All right, let's get moving to the next one. The answer was parabola. And here comes the next question. Okay. So Nivita, don't worry, we are here. We are doing all kinds of questions on all the topics which are there, which are very important, so that you brush through it. And make sure if you are attending today, make sure that you attend my previous class as well as the previous class before that, in case you have missed it. Here's the next question. Okay. So straight line, Mr. Abid, like I said, if you throw it in the direction of the field, then it will not deflect. Then it will keep on moving in that straight line. Okay. So this is again very, very important. If you have a dipole, okay, this is your dipole and this is basically your axis, and let's say this is your nothing but the equator, then we all know on the axis, the electric field is 2 times that of the electric field on the axis is 2 times on that of the equator. And the reason for that, you can see it very easily. Here the field lines are very, very dense. You can see that. Here the field lines are very dense, but as you go on the equator, the field lines are distributed. Here it is less, here it is more. There are more field lines on the axis. So hence, that's the reason for that. So on the axis, it is twice that of the equator. Perfecto. And I hope you remember the formula for that. In case you have forgotten, let me just quickly remind you. Electric field was Kp divided by r cube, and here you had 3 cos square theta plus 1. Okay, this theta is the angle between the dipole and the position vector. So angle between the dipole and the position vector, that's what theta is. So keep this in mind. Alright, moving ahead to the next one. Consider a region in which there are different charges but the total charge is 0. At a point which is outside the region, what do you think? Is the electric field necessarily 0? Is the dominant field inversely proportional to r square when r is large? Is the dominant field inversely proportional to r cube because when r is large, or is the work done to move the charged particle in that closed path away from the region will not be 0? What do you guys think? Okay, come on, my warriors, think. Okay, Dev saying C. Don't worry, concentrate, bacha. Okay, many of you are saying C and D. I can see that. Be careful about this. Be careful about this. See, the important statement is the total charge is 0. That's the most important line. So if you have some positive, negative, positive, negative, positive, negative, positive, negative, the total charge in this volume is 0. How much ever positives are there, that much ever negatives are there. The interesting thing is each one of them will form a dipole. Can you see that? They will form a dipole. You can have pairs of charges, so they will form dipoles. So the moment you start seeing dipole, we all know what is the field due to a dipole going to look like. The field due to a dipole, okay, it is K, P, something. The constants are not important. What is important is it is some constant divided by r cube. That is what is important. So each dipole produces a field which is inversely proportional to r cube. So if you add all the fields, they will all have r cube terms. Hence, r cube will be the answer. It is inversely proportional to r cube. But why is this large r mentioned? Remember, this formula is applicable only for short dipoles. Short dipole. What is the meaning of short dipole? That means you have a positive charge, you have a negative charge, and you are very far away. When you are very far away, those two charges look very close to each other. So that's why I call them as a short dipole. And only then you get that formula. When you are close, that formula is not applicable in case you have forgotten that. Okay, so be careful about it. Okay, chalo, let's get moving to the next question. Moving ahead, option C. Perfecto. No problem, Dhanush. We have tough questions. We have above average questions today, like I promised you, because I want you to score full marks in tomorrow's exam. And here is the next question. ABC is an equilateral triangle. 1 coulomb are placed at the corner. The electric intensity at point O will be. Come on, let's see how many of you can do this. Probably not more than 30 seconds. Yep. Very good. Okay. Let's see how many of you can get this. Outside the region, see, when you are outside, only then you can find the field due to a dipole. That's why outside the region was mentioned. Guys, this is straightforward. The answer is 0. The reason why it is 0 is because all the fields are going to just cancel out each other. All the fields are just going to cancel out each other. So net electric field will be 0. But I have a question. If this line was not there, instead, let's say instead of electrical intensity, you had electrical potential, then what will your answer be? Will the answer be 0? I don't think so. Reason is because potential is a scalar quantity. So there is no need of direction. They will not cancel. They will definitely not be 0. You have to add that. So potential at point O will be 3 times the potential due to any charge on the vertex. Any charge on the vertex, because all the charges are having the same magnitude. So you can find that out. Okay, I hope that is clear. Yes, then it will be 3 times of 1 upon 4 pi epsilon naught q divided by, that distance is given to be r, so q divided by r. So that's what it will be. Not D option, D has r square. Be careful, D has r square, so this square should not be there. Okay, only r should be there because this is potential. Do not make that silly mistake. Okay, very good, very good. Yes, be careful. All right, let's get moving to the next question coming up on your screen. There are two dipoles of moment p and 64p. They are placed opposite in direction on a line which is at a distance of 25 centimeters from each other. So p and 64p are 25 centimeters away from each other. The field will be 0 at a point between the dipoles whose distance from the dipole moment p is how much? Very interesting question. Let's see how many of you can do this. Some of you have already started saying A or D. Okay. Come on, my warriors. Don't worry, Mahima. Just stay tuned, stay cool. Watch how we are solving. You might at least get 4 or 5 questions out of this, maybe tomorrow, and at least you will get those marks. So don't worry. Maybe if you don't attend these sessions, then you will even not get those marks. So at least something is better than nothing. Remember that. Okay, so I'll tell you what you can do. So first of all, one dipole is over here. Another dipole is over here, so this is 64p. You want a point where the net field will be 0. So let's say that point is here, and let's say that distance from this is x, and from here it is y. So the field due to this dipole will be here, the field due to this dipole will be here. So let's say this is E1, this is E2. So for the net field to be 0, E1 magnitude wise should be E2. Basically they should cancel out each other. The field due to this and the field due to this should cancel out each other. So what is the field due to a dipole on the axis? Remember, this is the axis of the dipole. So just use that formula. So K into 2 into P divided by x cube will be equal to K into 2. Why the 2? Because on the axis the dipole's field is twice, so that 2 comes over there, and E2 will be 64p divided by y cube. Now I think a lot of things will get cancelled right over here, like k, 2, p. That's it. So I think I will get y cube divided by x cube is 64. So y by x is equal to 4 by 1, because 64 is the cube of 4, correct? Well, so y by x is 4 by 1. So now the total distance is already given. Total distance between them is 25 centimeter. Divide it in the ratio of 4:1. Divide it in the ratio of 4:1. Come on, it's very obvious now. 25, if you divide it into 5 parts, each part will be 5 centimeter. Each part will be 5 centimeters. So y will be nothing but how much? 20 centimeters. And x will be nothing but 5 centimeters. But the question is distance from the dipole moment P. That means x is asked. So hence the answer is option A. Done. Very good. Very good. Excellent. You should give yourself a pat on your back. Perfecto. Moving ahead to the next question. Let me tell you, all those of you who are joining in late, the PDF of today's session will be available to you in our Telegram channel group. So do not forget to join the Telegram channel link, and you will get not just today's PDF but also my NCERT underline. I have underlined all the NCERT important points, formulas. It's all uploaded in the Telegram group. Moving ahead to the next chapter on potentials and capacitance. First question coming up. The electrical potential at certain point in XYZ form is given. And the question is, what is the field at 1, 0, 2 in volts per meter? Very interesting. Okay, Tharul, I'll tell you what to do after the session towards the end. Okay, what you should do after this session. Everything I'm going to give you, the guidance, all right, for all of that. Okay, let's see what to do for this. If voltage is given, field is asked, I know what to do. E is minus dV by dr, but here voltage is a function of x only. Can you see only x is there? So dV by dx. So it will be minus d by dx of 4x square, which is nothing but 4x square's derivative is 8x, so minus 8x, but the value of x that you should put is 1 meter. So that will be minus 8 into 1, which is minus 8. That is your electric field in volts per meter. So minus 8 means 8 along negative x-axis. That's it. Option A. Option A. That's it. Done, done, done. Very good, very good, very good. So Mahan, this session will be at least for 2 hours. Okay, let's move ahead to the next question coming up on your screen. There is a capacitor. You charge it by a battery. The battery is removed and you add another identical uncharged capacitor in parallel to it. The total energy of the system because of this process will change by how much? Let's see how many of you can get this. Many students got the previous question. I am very proud of you. Keep spreading this, keep chatting and keep spreading this joy of learning. Very good, very good, very good. Let's see how many of you can get this question. So first of all, we have a capacitor, we have a battery. Okay, so this is E, this is C. So the charge on it initially will be C into E. The initial energy will be just half, Q square by C. That's what it will be. The initial energy will be half Q square by C. Now, when you disconnect that battery, then the charge on the capacitor will still remain. The charge on the capacitor will still remain. Now, what you have done is you have connected, another uncharged capacitor to it. So what will happen? The charge will get distributed, and because both capacitors are equal, they will have equal distribution. So eventually both the capacitors will have Q by 2 charge. So what is the final energy? So the final energy will be 2 times energy of each capacitor. And what is energy of each capacitor? Half Q square, but Q is not Q, it is Q by 2 whole square by C. 2 gets cancelled, half square is 1/4, so 1/4 Q square by C. If you notice this 1/4 Q square by C and compare it over there, this is actually half into nothing but half Q square by C. This quantity over here is the initial energy. So it has become half times. So it decreases by a factor of 2. Are you able to see that? Very good. So if the capacitors are connected in series, nothing will happen because the circuit will not be complete. So unless you join it, okay, so if you have capacitors in series, then nothing will happen. This end is not connected to this end, that's it, gone. And if you connect by chance this to this point, then this diagram is same as this diagram. There is no difference. It's just that you have to tilt the capacitor. Okay, so the correct answer is option B. Perfecto. Moving ahead to the next question. Here it is. Yep. So next question, Q, minus Q, plus Q. Minus Q are placed on the vertices of a square ABCD. So visualize a square ABCD and only then proceed with the question. So you have a square which is A, B, C, D. You are placing those charges. E is the field, V is the potential. Now you interchange the charges as mentioned. The question is, what will change, what will not change? Think about it. Come on, think about it. What will change? So yeah, it cannot be connected in series. Yashika, I would request you to please rewind back the session little bit and you can watch it again, okay, in detail later on. Okay, for now just concentrate on the session. Okay, thank you so much. Yes, I'm going to give you a short break, don't worry. Okay, let's see if you can get this question. Well, Q minus Q plus Q again and minus Q. This is the initial arrangement. Plus Q and plus Q will cancel their fields. Minus Q and minus Q will also cancel their field. In fact, the net field is going to be 0 and potential will be there. Potential, you can see plus Q and plus Q will give some potential. Minus Q and minus Q will also give the potential. In fact, the potential will also be 0. Now, see, if you just change the order, let's say, again, what you're doing, A and B are interchanged with those at D and C. So A and B you bring over here and D and C you bring it over here. What does it mean? The plus charges, sorry, the minus charges is here, the plus charge is there and A's charge has come over here, B's charge has come over here. Now what happens? It's the same thing. These two forces will cancel, these two forces will cancel, net field will still be 0 and net potential will still be 0. Nothing will change. So E and V will both remain unchanged. That's the answer. Many of you said D, many of you said B also. That's wrong. This was not charge, this was change. This will change. Okay, so B and D are wrong, guys. Be careful. Many of you made a mistake. Nothing changed. See what has happened. Both positive charges cancel their fields. Both negative charges cancel the field. Field is 0. Potential wise also equal, because same positive charges, same negative charges, same distance. So before and after, the situation is same only. So nothing has changed. Is that understood? Okay. All right. Chalo, simple girl. Come on, start posting the answers. Maybe I'll take a name. Yep. So I think Deepali made a mistake in the arrangement. Be very careful. Okay. Yes, you can also do it from common sense. Very good. Yeah. Okay. Next question coming up on your screen. A parallel plate capacitor with air as the medium between the plates has a capacitance of 30 millifarad. The area of the capacitor is divided into two equal halves filled with two different dielectric medium. The new capacitance of the system will be. Okay. Thank you, Ashish, for loving it. Afreen, I do not know how the paper will be. Nobody knows. If somebody is telling you that the paper is going to be like this, then they are lying. Okay. But I expect, so we can only expect. The expectation is it will be average. At max, few questions can be little bit tough. Don't worry. Okay. So let's see if we can solve this question. Parallel plate capacitor. So let's do this. Parallel plate capacitor. The capacitance is, 30 millifarad. Let's see this. So this is 30 millifarad. Because it's divided into two equal halves and then filled with the two medium. Okay. So here is what I will do. I will first of all divide it like this. I have not even filled it with anything. This 30, when you divide it like this, it becomes in parallel. In parallel, the capacitances add. So this plus this should give me 30. And because it is equal halves, so this should be 15 millifarad. This should be also 15 millifarad. Agreed, everyone? Because I have divided into equal halves, 15 will give you 30. Now, let's say you add some material. Here, K is equal to 3. And here also you add some material. Here, K is equal to 6. When you add something, capacitance increases K times. So this 15 into 3, what will be the new capacitance? It will be 45 millifarad. And here 15 into 6, what is it? Come on, it is going to be 90 millifarad. Perfect. Now think, 45 and 90 are in parallel. So what will happen to the effective capacitance? The C effective, just add it, 45 plus 90, which is 135 millifarad. So is it there? Yes, it is there. Just check this out. Everybody getting it? Perfecto. Perfecto. C for cricket, C for capto. Excelente. Moving ahead. Yes, 135. Next question on equivalent. Equivalent capacitance. A network of 6 capacitors, each of value C, is made as shown. Find the equivalent capacitance between A and B. Let's see how many of you can get this very quickly. Okay, so first of all, I don't know whether you can see this, that this is a wire. So this point and this point have same potential. This point and this point also have same potential. So this capacitor, instead of connecting it here, I might as well connect it here. It's one and the same thing. So this point, what am I trying to do? I'm just going to take it over here, and this point, oops, sorry, my bad, not this point. This point and this point are at the same potential. So this point, I can just take it probably over here, because this cross and this cross are at the same potential. So if you redraw the circuit, probably it's going to look something like this. This is point A. This capacitor, I will connect it across this capacitor. So it will look something like this. Okay. Then this wire is connected to this capacitor. So this wire is connected to this capacitor. Fair enough. Now these two capacitors are done. Okay. There is another capacitor here. So I'll just draw that another capacitor. This capacitor is connected right across this capacitor. So I can just show this capacitor connected across this capacitor, and this wire is directly connected to B. Now it becomes simple. This is C, this is C. So these two are in parallel, so this will be 2C. These two are in parallel, so this will be also 2C. Next, this C and this 2C are in series. Okay, so how will the equivalent look like? Think this is A, C and 2C are in series. So equivalent 2C into C divided by 2C plus C, which is 2C divided by 3, correct? So you will have 2C by 3 here, and you will also have another 2C by 3 here, and this is B. What are these two in? They both are in, again, parallel. Can you see they both are in parallel? So the effective capacitance will be 2C by 3 plus 2C by 3. Both are in parallel, so it will be nothing but 4C divided by 3, which is option C. Done, done. Very good. Yes, Sri Yogesh, you are going to get it. PDF, don't worry. Yeah, you're going to get it. By the end of today's session, you will get it. Okay, perfect. So the idea is to identify the points which are at the same potential, and that's what I have done. I've just connected this point here, this point, this point, this point, this point, same potential. So just connect it over here because there is a wire, and then redraw the circuit. It will become easy. That's all. It will become easy peasy lemon squeezy because it will become parallel and series circuit. That's all. Okay, chalo, let's get moving to the next question. In the figure, Q is at rest at the center of a circle. Work done is maximum when another charge is taken from this point to K, L, M or N. Which point do you think you should take the another charge so that the work done is maximum? Come on. Come on. Think carefully. Come on, my warriors. Guys, don't believe any random rumors or virus. A lot of elements might just tell you some random nonsense on the chat box. Don't value it. Okay, just concentrate on the session. All right. Cool. So option A or C or D. Okay, clearly you guys are getting it wrong. Yes. You will get it on Vedantu Enthuse channel. Okay, many of you got it wrong. The answer is K, which is option A. Oops. Guys, you forgot electric force. Electric force is conservative. And you can see for this charge, this point and this point are separated by some distance. This point and this point are also separated by the same distance. This point and this point are also separated by the same distance. This point and this point separated by same distance. So this, all points are equipotential. So work done will be 0 because you are going on the same equipotential path. Makes sense? Makes sense, everyone? This point, equidistant. Tuck. You just got confused. Only when you go from here to here, now you are going on a different potential. You are having some potential difference over here. So that's why work will be done. Hence, the answer is option A. Got it? Very good, Indrani. Very good, Priya. Very good, Darshini. Yes. Excellent. So where can you get the PDF? The PDF will be available in the Telegram channel link, but not now. It will take few hours. So that's what it is. Next question. 3 charges are placed at the vertices of an equilateral triangle of side as shown. The net electrostatical energy of the system is going to be how much? Next question. What is the net electrostatical potential energy of this particular system? Q, and Q out here. All right, figure this out. The net electrostatical potential energy is actually given to be 0. Then what is the value of Q? Okay, energy is not asked, Q is asked. Figure this out. Okay, D. Okay. The net electrical energy is 0. The question is, what is capital Q? What is capital Q? Think carefully. Now, in order to find the total energy of the system, what you need to do is find out energy of these 2 points, energy of these 2 points, and energy of these 2 points. Add them up, you will get the total energy. So the total energy of the system will be K Q Q divided by the side length is L plus K Q Q divided by side length is L plus K Q small q divided by L. It's mentioned that the system's energy is 0. So therefore 0 is equal to K is same, L is same, small q is also common. So I'll just get Q plus small q plus capital Q. So therefore 2q plus small q is equal to 0. Therefore what has been asked? Capital Q is equal to. So capital Q is equal to minus q by 2. Hence that's the answer. That's the answer. Yep, many of you got it wrong. Many of you said the D before. Wrong. D is not correct. Okay, so this is not going to be 0. If this is 0, then these two will have energy between them. But the question says the total energy is 0. Be careful about it. So that's the answer. 0 is going to come only when you keep the capital Q as minus q by 2. Next questions are going to be from current electricity. All right, very good Lanzi, very good Venkata, very good Akib. All right, moving on to the next one. When a current I is set up in a wire of radius r, the drift speed is Vd. If the same current is set up through a wire of radius 2r, then what is the new drift speed going to be? Come on, think about it. Come on, think. Roshan, the session will be at least for 2-3 hours, okay? 2 hours maybe. Okay, so think about it. The current is set up in a wire of radius r. The drift speed is this much. If the same current is set up in a wire of radius 2 times the previous one, what do you think is the new drift speed going to be? Figure this out. What is the formula that you're going to use? Is there a formula? I think there is. Current is NVIDIA. Current is NVIDIA graphics card. I have been telling you about this. Okay, so N is as it is, drift speed is as it is, E is as it is, area is pi r square. So this is what it is. Now think that current is the same. Current is the same. So this is constant. N is same because it is the same material. Okay, it's the same wire. Then E is electron charge, pi is also constant. The only thing that can change is R. Now what has R become? It has become 2R. So if R becomes 2 times, square of R, okay, square of R will become how many times? 4 times. But R square into drift speed is a constant. Current is same. So therefore, the drift speed should become 1 by 4 times so that their product remains constant. Hence, it will become 1/4. 1/4. All those of you said A, B or C are wrong. A, there you go. Okay, so very important concepts. All important concepts are being covered today. Very important high weightage chapters and subtopics are being covered today and questions based on that. So that's what our aim is, to cover those topics via questions. So let's get moving to the next question. Very high weightage questions. A wire of certain resistance is stretched to twice the length of its original length. The new resistance of the wire should be based on resistance. Come on, think about it. Yep. So Mahant, I hope you understood. Yep. Okay, Janvi, I have mentioned the deleted topics on day 1 of the marathon session. Check my previous day's session. I have mentioned which topic is deleted, which is not. I have also uploaded it on the Telegram channel group. Okay, let's see. C and D, many students are confused. Resistance is rho L by A. Now, if you had a wire of certain length and certain area, you stretch it to twice its length. So basically, what you are doing is you are elongating it. Then, if the length becomes twice, the area will become half. Why is that so? Because volume, which is area into length, this is basically a constant. So if length increases, area decreases. So length becomes twice, area becomes half. So hence, think about it, the new resistance will be rho into length has become twice, area has become half. So it will become 2 2s are 4, 4 rho L by A. So it will become 4 times. So 4 ohm into 4. So 4 times of 4 is 16. That's the answer. Understood? Many students make the mistake. All right. Very good. Very good. Excellent. Moving ahead to the next question coming up on your screen. Apply Kirchhoff's law quickly and let me know what is the current which is over here. Apply Kirchhoff's laws and figure out what is the current going to be in that particular segment. Figure this out. This is very easy. I'm pretty sure you'll be able to do this. Come on. Many of you are saying C. Kamlesh, took your name. Chalo, get set, go. And I hope you guys have already smashed the like button. In case you have forgotten to smash the like button, please do that and also hit the subscribe button. Alright, so 5 and 4 is going to become 9. 5 plus 4 is 9. Now 9 and 2 is going to be 11. So 9 and 2 is going to be 11. But out of that, 1 ampere is coming. So this should be 10 amperes because 1 plus 10 is 11. What is coming in should go out. Fair enough, coming in should go out. So 11 amperes coming in, 11 amperes going out, 1 plus 10 is 11. So out of the 10 amperes, 3 is going here, obviously 7 amperes will remain here. So hence the answer is C. Fair enough, very good. C with fire, AK beats. Excellent. Moving ahead to the next question. Two cells of EMF approximately 5 volt and 10 volt are to be accurately compared using a potentiometer of length 400 centimeter. Okay, the battery, so very theoretical question, conceptual. A battery that runs the potentiometer should have voltage of 8 volts. The battery can have any volt, but the resistance should be adjusted so that the drop slightly exceeds 10. First portion of that wire should have 10 volts. The potentiometer is usually used for comparing resistances and not voltages. Very interesting question. Come on, my warriors. All right, Angel Joel saying balloons. Mahan saying B with a fire. Ravi Chandran saying B. Gokul also saying B. All right, everybody has confirmed B. All right, so I think the answer should be B. Yes, it is. I'll tell you why. Because when you have this battery, okay, and there is this resistance, this is in primary circuit, okay, this is your potentiometer wire. Now when you have connected a battery over here, okay, via this galvanometer, this is your jockey point. So if the two cells are 5 volt and 10 volt, take the higher voltage, let's say 10 volts. So the voltage between A and J, the voltage between A and J will be at least 10 volts. Will be in fact 10 volts. So between A and B, the voltage should be more than 10 volts. So if this is more than 10 volts, that means this battery over here should be also more than 10 volts. So hence you can have a battery of 15 volts, but you can adjust this resistance so that this is maybe, I don't know, 12 volts. So that between these 2 points you get 10 volts. So it is allowed. But you cannot have a battery which is less than 10, then you will never get null deflection. So the null deflection can be only obtained when the primary driving circuit has more voltage than the secondary circuit's voltage. Okay, here is the next question coming up on your screen. Two resistances connected in the two gaps of a meter bridge. The balance is 10 centimeters from the zero end. A resistance of 20 ohm is connected in series with the smaller of the two. The null point shifts by 20 centimeter. What is the value of the bigger resistance? What is the value of the bigger resistance? Think about it. Think carefully. Come on, my warriors. Yes, thank you, Bansi, for reminding me. Okay, this is going to take some time. Let's see if you can get this correctly within a minute. I'm going to give you a 1 minute timer. Okay, chalo, 1 minute timer, not more than that. You have to solve it. You have to solve it. Without solving, you'll not get it. Come on, Devarita Ghosh. Chalo, chalu karo. Figure this question out. Very good, Afreen. This is the right way to be present and you are present at the right place. Okay. Let's see how many of you can get this. Akib, like I mentioned before, you're going to get the PDF in few hours. Don't worry about it. Okay. Many of you have got this wrong. I'm surprised. Many of you have got this wrong, but some of you have. Oh, now you're getting it correct. Now you guys are getting it correct. Very good. Now I'm proud of you. Excelente, excelente, and the time is up. See, when you are given time, you do it correctly. At the, in a haste, in a hurry, you are making mistakes. So be careful. So what has happened is, okay, let us just show this diagram. This was one resistance. This is another resistance. This is a potentiometer, and this is a galvanometer, like this. Okay, so this is, let's say R1. Let's say this is R2, and if you write the equation, it will look something like this. R1 by R2. First balancing length was 10 centimeter. So 10. So the remaining will be 90. Fair enough. So this is 1 by 9. So basically 9 R1 is equal to R2. That's one equation. Second time what is happening? R1 by R2, but I think R1 is changed. What you have done, you have added a resistance of 20 ohm in series with the smaller resistance. Smaller of these two, who is smaller? R1 is smaller. So basically you have added how much? 20 ohm. So then the balancing length shifts to 20 centimeters, not by, to. So this is 20 and this is 80. So 20 by 80 is nothing but 1/4. Cross multiply this. Let's see what do we get. So we'll get 4 R1, 4 into 20, 80 is equal to, this is going to be 2 R2. Now we know what R2 is. R2 is nothing but, check this out. Oh, sorry. My bad. Not 2 R2, just R2. Yeah. Now check what R2 is. R2 is nothing but 9 R1. R2 is nothing but 9 R1. So this is 4 R1 plus 80. So basically 80 will be nothing but 5 R1. So R1 will be nothing but 16. So we got R1. The question is the bigger resistance. So bigger resistance is R2. So R2 will be nothing but 9 into R1, which is 16, which is nothing but 144 ohms. So hence option B is correct. Yep. It's not 70 by 80. It is 20 by 80. It is not 70. It is 20. Okay, it is 20. It is 20 by 80. Okay, it's not 70 by 80. Perfect. Got it? Excellent. So this is the logic behind it. Ratio of the resistance is ratio of the length. If this is 10, this is 90. If this is 20, then this is 80. Okay, but they will always complement each other. Perfect. Option B is correct. Moving ahead to the next question. I hope Shreya, your doubt is cleared. Going ahead to the case study. Ready with the case study? Okay, I need one small thing from you guys. You have to take the screenshot of the passage, because I can't put the passage and the question on the same screen. It will become very teeny-meeny. Okay, so you need to take the screenshot. So this symbol stands for the screenshot. Take the screenshot of this passage so that you can refer to this while solving questions. And as soon as you have taken the screenshot, put up a heart in the chat box so that I know that your screenshot is done. You have read through the passage and then we are ready for solving the questions. Okay. Come on. Why R1 is smaller? Because R1 by R2 was 1 by 9. So if R1 by R2 is 1 by 9, R1 is smaller, R2 is bigger. Very good. Come on, keep the hearts coming. Once you are done with the particular screenshot, then I will show you the question. Read through the passage very quickly. Okay, done. Let's do this. Which of the following is correct statement? The first question coming up on your screen. Very good, Shreyas. Okay, so let's see if you can get this. Which of the following is correct? Heat produced is independent of the current. Heat produced varies inversely as the current. Heat produced varies directly as the square of the current. Heat produced varies inversely as the square of the current. Very simple. Very good. C. Okay. Now, a lot of students have this doubt. Sir, I did not get this. Power is V into I, but power is also I squared into R. So, is power directly proportional to current or power directly proportional to I square? Be careful. Think now. I have confused you a little bit. Yeah. Abhinand has got it right. In passage, half the times it is something which you know only. Will you say it is proportional to current or directly proportional to square of the current? Why square? Why not just proportional to current? think the voltage across the device might not be constant. Okay, so you have no control on the voltage across that. So when you have a particular device, the only thing that you know is its resistance. Resistance is known. Voltage across it, I don't know. Voltage will change according to the current and all of that. So it's better to always go with resistance is constant for that particular device, and you might change the voltage, that's okay, but irrespective of that, resistance won't change. Even if you apply more voltage, resistance stays the same. That's why you will go with this particular formula. Okay, so keep this in mind. Yep. Going ahead, yes, heat produced is proportional to the square of the current. If the coil of the heater is cut into half, what would happen to the heat produced? Let's see how many of you can get this. So Devarita, what happens is, like I mentioned, the device is the same. So more current will flow if more voltage is applied, but resistance will remain same. So the choice of formula that you will make is I squared R, not VI, because R is same. Okay. B or A? Oh my God, students are confused. Wow. Look at that, guys. Be very careful. You guys are making a silly mistake, yeah? Be careful. So many of you are making silly mistakes. Think carefully. Think carefully again. I'll give you some time. Think carefully. What has happened? The length has become halved because you have cut it into half, right? So just imagine you had this conductor, you break it into half. So length has become half times. Okay. If length has become half times, each resistance will be half of the previous value. Correct? Makes sense? Now if the resistance becomes half of the previous value, then what will happen? If you connect, earlier this was connected across a battery. So the power loss was V squared by R. Correct? This whole thing had resistance R. Now if you connect this across the same battery, then what will be the new power loss? The new power loss will be V square by R by 2. V square by R by 2. Be careful. Therefore, it will be 2 times V square by R, which is 2 times of the old power. It will become double. Yes. Lot of you made the mistake. You didn't know which formula to use. Sir, V square by R or I squared R. Don't do this mistake. You see what has happened. There is a heater coil. What is that heater coil connected to? To some source, to some supply. So earlier the resistance was R. Now you cut half of it and connect it to the same supply. So what was constant? Voltage was constant, not current. Current will change. So those of you who used I squared R, they are wrong. This current is not going to be the same. Current will change. Be careful. Why are we not considering area? Very good question, Neha Ramesh. The question does not say it is compressed. See, there is a difference. In the previous question, the rod was stretched. When you stretch or compress, the area changes. But when you cut a rod, the area does not change. So understand. Or when you join two rods, area does not change. So you should know when to change the area and when not to change the area. Is this clear? Is this clear? So don't get confused. Sir, in the previous question you told length became half, so area became double and all of that. So what happened to that area? So area has not changed because I have actually cut it. Yep. Very good. So power is directly proportional to heat, bacha. So even if you do heat, heat will be power into time. Na? So it's the same thing. Anyways, the time value will get cancelled. Okay. So it will get cancelled. Power is directly proportional to heat. So don't worry about the heat formula. It's just having one time over there. Harini, it does not matter. Power is proportional, doesn't matter. Okay. So, yep. If you join lengths of different cross section, then treat it like two different resistors, R1 and R2, and then add it, R1 plus R2. That's what you will do. Okay? Yes. Clear? Everybody give me a thumbs up if you have understood, like Rishabh. Very good, Himanshu. Very good. See if you guys have understood. Let's get going then. Okay. 25 watt bulb and 100 watt bulb are joined in series. Okay. And they are connected to the mains. Which bulb will glow brighter? Think about this. Very good. I can see all the thumbs up. Now think about the next one. Which bulb will glow brighter? See, whenever you have these questions now, think this way. A bulb is always connected to your standard supply. Let's say V volts. This is your standard supply. And we all know that the power of the bulb is always given by V square by R, not I squared R, because the voltage is constant. That rating in the bulbs that you get or tube light is always for a fixed voltage. So the bulb which has lower wattage has more resistance. So power of 25 is less. So resistance of 25 is more than resistance of 100 watt bulb. Now when you connect them in series, so this is your bulb of 25 watt power and this is your bulb of 100 watt power. So this is resistance of 25, this is resistance of 100. Now think, if they are connected in series, who will have more voltage drop? Now their voltages won't be the same. Think about it. Voltages won't be the same, current will be the same. In fact, now the total voltage V is divided between two voltages V1 and V2. It will drop here V1, here it will drop V2, and V1 will be I into R. R is R25. V2 will be I into R100. Who is more? Who is more? Think about it. Think about it. Who is more? Where would the voltage drop be more? Okay. Or okay, now you can see that the current is same, the voltage will be more here, V1 will be more than V2. But do I need voltage? Let's think about it. Let's think about it. I don't think I'll need voltage. I just need the brightness, right? So I don't think I need the voltage. So that was not needed. Anyways, I just need the power. So the power of this bulb, will be I squared into R25. The power of this bulb will be nothing but I squared into R of 100. Current is same. Why is the current same? Because it is in series. So this was not needed. Okay, I'll just erase this. This was not needed. So basically the one which has more resistance will also have more power. That's it. So this relationship helps me find out that the resistance of 25 ohms is more. So the lower wattage bulb will glow brighter. As simple as that. So that answer should be B. Done, done, done. Got it? Yes. What if they are connected in parallel? Acha, let's do this. What if the 25 watt bulb and 100 watt bulb, 25 watt and 100 watt bulb are in parallel? Then which one will glow brighter? Come on, answer this. What about in parallel? Then understand the voltages are same. Voltages are same. So the power that formula that you'll use is V squared by R. So since voltage is same, the one with lower resistance will have higher power. Who had lower resistance? 100 watt. So that case 100 will be the answer. Understood? Understood? Yup. Very good. Yes, very good. Both bulbs will not glow the same brightness because 100 watt and 25 watt, obviously their wattages are different, resistance are different. Very good. These kind of questions can come in case studies, so you have to be careful. So in mixed combination, what you do, you calculate in individual powers. Depending on what is same, what is not same, calculate individual values of each bulb and then you compare. Whichever bulb has more power effectively will have more brightness. That's all. Okay. Yes. Let's get moving. A rigid container with a thermally insulated walls or something is containing a coil of certain resistance carrying certain current. What is the change in the internal energy of that system after 5 minutes? Yes, Hari Prakash. Very true. Okay. Let's see how many of you can get this. Yeah, definitely you can ask Ishrat. Definitely. D, A. Be careful about what you are answering. So the internal energy change is basically the heat which is produced. The heat which is produced is I squared R into T. What is current? Current is 1. What is resistance? 100. What is the time? 5 minutes. So 5 into 60. That's it. So I squared RT, khatam. So 6 5s are 30 and 0 0 0, so 10 to the power 3, so 30 kilojoules. That should be the answer, option D. Very good, perfecto. That's it. Now let's take a small teeny mini break, 5-minute break, 5 to 7 minutes break, and then we'll return for the next part. What are we going to do next? Moving charges and magnetism and all of that, okay? And then magnetic sources, everything. So we are going to do magnetism, then we are going to do EMI, we are going to do AC, all of this, Biot-Savart's law, Ampere's law, all the questions on this. So I'll return back maybe in just another 5 to 10 minutes, not more than that. So the countdown timer, I'm just going to put it right over here. Okay, so maybe 7 minutes or 8 minutes. So starting now. Hello. Good afternoon. Welcome. Yes, welcome back. Let's get moving to the next leg of our class. Welcome aboard, my warriors. Let's all move to magnetism, and then we will also talk about Earth's magnetism and magnetic sources, effects of magnetic field, all of this right now. And remember, do not forget to smash the subscribe and also hit the like button in case you have forgotten to do so. Show your full support in full energy. Let's move to our next chapter, moving charges and magnetism. Here's the first question coming up on your screen. In a millivolt meter, or rather a millivolt meter of 25 millivolt range is to be converted into an ammeter of 25 ampere range. The value required in the shunt is how much? Very good question. Let's see how we can do this. Perfect question for all of you. Is going to need some amount of effort to get to this. Prasanta, apart from these questions, I'm going to tell you what else you need to do. Okay, also watch my previous and before that also another lecture I had conducted. Please watch those sessions. Those are very, very important apart from today's session. So what do you think is the answer? A? Okay, I'll tell you what. See, you have a voltmeter. Okay, this is a voltmeter. And the range is given to be 25 millivolt. This is nothing but like a resistor. So this is the resistance of the voltmeter. And the voltage drop across that is 25 millivolts. That means you can have a maximum voltage drop of 25 millivolts across it. If you want to convert it into an ammeter, obviously you need to connect something in shunt. So you need to connect something in parallel. So this is your shunt resistance. So the value required in the shunt is, so RS is what has been asked. The range of that ammeter is 25. That means if 25 amperes comes inside, most of it will get bypassed here. A small current will flow here. Now, here is my simple question to you. Guys, this is a voltmeter, and what does a voltmeter do? It measures voltage, and that's because it has a very high resistance. So this resistance is going to be very, very large. If this is going to be very large because it's a voltmeter, what will be the current flowing here? It will be negligible, right? It will be negligible. So most of the current is going to flow here. So this will be approximately 25 amperes. Everybody gets this? This will be also approximately 25 amperes. Now, what do we know? The voltage across these 2 points is 25 millivolts, and we all know voltage is current into resistance. Use that, Ohm's law. Voltage is 25, milli is 10 to the power minus 3, current is 25, resistance in the shunt I don't know, 25 goes, RS is basically 0.01 ohm, which is option A. Very good, I can see all your chats, perfecto. So at the end of the day, whenever you see a voltmeter or an ammeter problem, remember this is nothing but series and parallel resistors. If you solve the questions like that, it's going to be very easy, else you will just waste your time. Option A is correct. Moving ahead to the next one. Okay, how will be the resistance of the voltmeter? It will be very large. Okay, so the shunt will be very low. Yes. So it's not like that, Roman. If somebody is saying, sir, we should choose the lowest of the value. No, that is not true. What if there was one more option and A option was correct? Hai na? So you cannot do that. Don't choose the lowest value. That is a wrong thinking. Don't do that. Okay, next question. A current carrying loop is placed in uniform field. The torque on it does not depend on area, number, shape, angle. Which of the following? Come on, let's see. Okay, many of you are saying C. Let's see whether it is correct. The torque is mb sine theta and magnetic moment is NIA. So area of the loop, yes, it depends. Angle, Yes, it depends. And area of the loop is done. Number of turns? Yes, it depends. Shape? No. So answer C. Option C is correct. It does not depend on the shape of the loop. Perfecto. Very good. Next question coming up on your screen. There is an electron and a proton. They are moving along the same direction with the same kinetic energy. They enter a region of uniform magnetic field perpendicular to the velocity. The dependence of radius on the path of the masses is, come on, figure this out. Okay, just figure this out. Come on, my warriors, think about this. Miyaji, I will reply, bacha. There are so many messages. I have finished my backlog of few messages. I'll reply to you. Okay. D and A. Many students are confused over here. So the radius is basically given by M into V divided by QB. The moment you say this, you will be like, sir, it is option A. That is wrong. Be careful. The kinetic energies are same. So first of all, M into V, you write it as momentum, and this will be QB. And we all know that kinetic energy is P square by 2M. Correct? P square by 2M. So basically P square is 2mk. So P will be root of 2mk. So use that fact over here. So write it as root of 2mk over here. So that's the momentum, and divided by QB. Now everything is fine. See, charge is electron and proton have the same charge. Magnetic field is same. Kinetic energy is same. Only mass is different. So from here you can see R is directly proportional to root of M. 2 is a constant. So hence option B is correct. Yeah. So many of you missed this part, that it had same kinetic energy. So if that was not read, then you would have marked option A, which is definitely wrong. All right. Moving ahead to the next question. A circular arc of wire subtends an angle of pi by 2, 90 degrees at the center. If it carries a current I and its radius of curvature is R, then the magnetic field at the center of the arc is how much? If it is not mentioned kinetic energy, then at least speed should be mentioned. Is the speed same or not same? So if speed same is mentioned, then you will go with option A for the previous question. Okay, Savitri? Alright, B and D. Students are confused again. Guys, you are doing a small blunder. Be careful. This is 90 degrees or pi by 2 radians. Correct? Now the question is, for this wire carrying current, how much is the field at the center? We all know if it was a complete loop, so field due to a complete loop is mu naught I by 2R. But the field due to that arc, which is essentially 1/4 of that loop, so just multiplied by 1/4. So 1/4 of mu naught I by 2R. 2 4s are 8. So that's option D. What are you guys doing? It is not B. Read the question. It is just 1/4. Pi by 2 is nothing but 90 degrees. You guys forgot it. So 1/4 of the loop will be only contributing in the magnetic field. Got it? Excellent. Moving ahead to the next question coming up on your screen. There is a wire of length L meters which carries current I amperes, and it is bent in the form of a circle. The new magnitude of its magnetic moment is, come on my warriors, think. Come on, figure this out. What do you think should be the magnetic moment? Okay, I'll tell you what. This is a wire of length L. You convert it into a circle. So the moment you convert it into a circle, it will have some radius. We all know that length will be 2 pi r, correct? So radius will be L divided by 2 pi. Now every loop which carries some current, it also has a magnetic moment. So we can find that magnetic moment. What is the formula? The formula is NIA, but N is 1, current is current, area is nothing but pi r square. So I into pi, r is L by 2 pi. So L by 2 pi whole square. So I think you will get I, pi will go, one of the pi will remain, L square by 4 pi. So I think I L square by 4 pi. Is it option B? Just check this out. Yep, that's what it is. Perfecto. So The concept over here was the magnetic moment is number of turns into current into area. So any loop which is there, which has current, it also has magnetic dipole moment. That's what it is. Perfecto. Let's get moving. Yes, option B is correct. Oops. This question, I don't know why the answer came out over here. Okay, let's just solve this now. Okay, this, we are going to share the PDF. Okay, my bad. So, the question is, oh, I know why this was, I think this was supposed to be deleted, or there was a missing information. The area was not given. So I think that's why this slide has been, was supposed to be removed, but I think one of the slides just remained over here. But anyways, let's say if area was given, then the formula that you will use is B is equal to mu naught Ni. That's all. So magnetic field is given. Mu naught is, oh, we don't need the area. My bad. This is not the flux or anything. So this was just the field. So cool. So B is equal to mu naught Ni. Mu naught is 4 pi into 10 to the power minus 7. Okay. And number of turns per unit length is 20 per centimeter. So if it is per centimeter, that means 1 centimeter is 10 to the power minus 2 meters. And into the current, that current is something which I don't know. Field is 20 milli. Milli is nothing but 10 to the power minus 3. Okay, so what and all will get cancelled? 20 and 20 will get cancelled. This 10 to the power minus 2, this will become 10 to the power minus 5. Just take this out. 10 to the power minus 3 and 10 to the power minus 5 will become 10 to the power minus 2. Fair enough. So basically I'll get 1 is equal to 4 pi. 10 to the power minus 2 is 100 into current. So this will become just 25. So current will become 25 divided by pi. So pi is roughly 3 point something. So 3 8s are 24. So this will be approximately 8. So hence answer A will be correct. Yep. Okay. I hope this is clear. Okay. Great. Understood how to solve this question? Everybody understood? Everybody understood how to solve this? Yeah, that's all. Okay. Let's move on to the next one coming up on your screen. Here it is. Two straight parallel wires, both carrying 10 amperes in the same direction. They attract each other with a force of this many newtons. If now both the currents are doubled, what will be the new force of attraction? Let's see how many of you can get this. Two wires which carry current. In case you have forgotten about this, when the two wires carry current in the same direction, then they basically attract each other, and when they carry currents in the opposite direction, then they repel each other. In fact, that's how the unit of amperes was defined. So the question is, what is the force when the currents are doubled? So let me tell you the formula. The formula was mu naught I1 I2 length divided by 2 pi into distance. So this was the formula for the force of attraction or repulsion. If you take this current and make it 2 times, if you take this current and also make this 2 times, then what will happen? The net force will become how many times? 4 times, right? So if it becomes 4 times, so 4 into 10 to the power minus 3, which is option C. Very good. Option C is correct. D is wrong. Think again, Avni. Be careful. Subramaniam. Yep. Jevish, we are going to upload the PDF, but it will take some time for today's PDF. Yesterday's PDF should be up in a matter of time. Don't worry about it. Let's go to magnetism and matter. Okay. Let's do this. Magnetism and matter, the Earth's magnetism. That's the major topic over here. Let's see how many of you can do this question. Two identical bar magnets of length L, pole strength small m, magnetic moment capital M, placed perpendicular with their unlike poles in contact. What is the magnetic moment of the combination? What is the magnetic moment of the combination? Come on, figure this out. The magnetic moment of that combination. Draw the diagram. Things will be very easy for you. Okay. B or D? Some students are saying D. Alright, let's do this. Here we have. So we have, let's say, North Pole. This is South Pole. And they are perpendicular. So this is North Pole, this is South Pole. Why have I drawn like this? It's given with their unlike poles in contact. So the new magnetic moment will be the missing side. That's it, from north to south. That's it. This is the remaining part. So if this is M, obviously by Pythagoras, this will be M root 2. Hence, the correct answer will be this one. What is the use of pole strength? Not useful at all. What is the use of the length of the magnet? Not useful at all. Remember, magnetic dipole moment is a vector quantity. So you have to use vector addition. This vector plus this vector will be that vector. That's it. Root 2m. Correcto. That's the answer, like you can see over here. Next question coming up on your screen. Here it is. There is a place, on the earth, and the horizontal component of the magnetic field is this much Weber per meter square. The angle of dip is given. What is the vertical component of the earth's magnetic field? Come on, my warriors, figure this out. This is straightforward. What should be the answer? Figure this out. The horizontal component is given, the angle of dip is given. So horizontal is given, that means 0.36 into 10 to the power minus 4. I will just show it along the horizontal. The vertical will be somewhat like this, and the resultant will be over here. The question is, what is the vertical component? And this angle is given to be how much? 60 degrees. So I think you can use trigonometry over here, direct trigonometry. So what is it? Tan of 60. Tan of 60 is opposite by base. So it will be BV divided by 0.36 into 10 to the power minus 4. So BV will be equal to, tan 60 is how much? Root 3 into, take this guy over there. So 0.36 into 10 to the power minus 4. Root 3 is 1.73 into 0.36 into 10 to the power minus 4. Correct? So 17 and 3. So close to 17 3s are 51. 51. Say thoda zyada 17 4s are. Okay, so it will be somewhere here. Yes, 0.62. Yep. Correct. Check this out if it is understood. Yep, option D is correct. So you don't even have to sit and calculate. Just if you remember the tables, you can just think which option is closest to whatever approximations you have done. Accordingly, you can mark it. Yep. Let's get moving to the next one. At a place, the magnitudes of the horizontal and the vertical components are 0.3 and 0.6 overstated. The value of the angle of dip at that place will be. Come on, this is also straightforward. You should be able to do it. At a place, the horizontal and the total. Horizontal is this one. So it is 0.3. And this is vertical. And this is total. So the total is 0.6. The question is, what is the angle of dip? So obviously, you're going to do tan. No. You're going to use cos. So cos theta is basically 0.3 divided by 0.6, which is half. So if that is cos theta, what is the value of theta? Theta is 60 degrees. Be careful, it is not 45. You guys made a mistake. Some of you made a mistake over there. Be careful. It is option A, guys. Cos 60 is half. Yep, cos 60 is half. Very good, very good, very good. Chalo, we'll do a case study now. Now in the case study, you have to take the screenshot of it. Okay, be careful. You have to take the screenshot. This is the passage. Make sure you've taken the screenshot and put up a heart once you have taken the screenshot, because the questions are going to be based on it. I want you to refer to this in case you find any difficulty. Figure this out. Okay, chalo. Put up a heart once the screenshot is taken. Done, Venkata. Very good. Excellent. Come on, keep the hearts coming once you are done, so that I know you guys were ready for solving the questions. Perfecto. So this is a moving coil galvanometer. So one is suspended, one is pivoted, and in our syllabus we have pivoted type, and it is based on a fact that when current is moving in it, then it experiences torque, and this torque rotates it, but it is opposed by your spring. So let's start solving the questions. Let's do this. Very good, Sakshi. Very good, Himanshu. Okay. Assertion reason, I conducted a special class just few days back, just 2 days back. Only assertion reason, I conducted it for 5 hours. Assertion reason and case studies. So please watch those questions, how I am solving it, and make sure you also download the PDF so that you can even practice it at home. And then if you get stuck, you can watch the video. That's how you can do. So lots of assertion reasons. I mean, hundreds of them were done there. Okay, so moving coil galvanometer is an instrument where Come on. B, D. Yes. Some of you are saying A. Why is it A? It's D. It's a deflection instrument which gives deflection when current flows through the coil. It is used to measure resistance, no. Potential difference, no. EMF, no. Well, a lot of you might get confused. Sir, a galvanometer can be converted into ammeter or voltmeter, and voltmeter can measure the EMF. So is it not used to measure the EMF? Yes, but not directly. What galvanometer actually measures is the current, not EMF or not for anything else. Okay, keep this in mind. It can be used indirectly but not the direct application. To make the field radial in a moving coil galvanometer, this is theory based. The number of turns is small. The magnet is taken in the form of a horseshoe. The poles are of very strong magnets. The poles are cylindrically cut. Okay, come on, figure this out. What is the speciality? If you remember the construction of the galvanometer, then you know how the magnets are. Okay, D with the heart says Harita. See, in the moving coil galvanometer, if you have observed it, the bar magnets are slightly cut in a very peculiar shape. This is north, this is south, and this is how the field lines look like. This is how the field lines look like. You can see that. So this is basically your radial field, and the radial field comes because the magnets are cut in the form of a cylinder. So hence the poles are cylindrically cut. Option D. Yep, option D. Radial means this. From the center, you can see radial field. It's along the radius. Most of the field lines are along the radius. So that's why radial field. So because of that shape, the field is radial. Okay, that's what it is. Perfect. Option D. Moving to the next question. Yep. The deflection in a moving coil galvanometer is directly proportional to which of the following? Come on, figure this out. Which of the following is it proportional to? Think. Now, if you guys are finding all these questions very easy, then I'm guessing your preparation is going very well for JEE. So if you are preparing for JEE, CBSE board examination is a cakewalk. Right? Okay, B. Well, correcto. It is correct. The deflection, there was a simple formula I have told you again and again. Basketball, deflection. Okay, so think of this. Deflection is basically basketball. Okay, basketball divided by captain of that basketball team and into the current which is flowing in the team. Okay, so what is basketball? Basketball is NBA. You would have heard NBA basketball. So captain is C, deflection is theta, current is I. That's it. So you can see directly proportional to current, directly proportional to turns also. That's how it is. Very good. Perfecto. Moving to the next question. In a moving coil galvanometer having n turns carrying current I placed in the radial field, the torque acting on the coil is how much? Okay. How much is the torque acting on the coil? Figure this out. Figure this out. Come on, my warriors. You can use C, you can use K. It's one and the same thing. It depends on what symbol you want to use. Torsional constant. Keep this in mind. D. Nabi. Nabi is the answer. Nabi. Yes, Nabi is the answer. Why is Nabi the answer? Because NIA, National Investigation Agency, this is your magnetic moment. Into B, this will give you your torque. This will give you your torque. So Nabi, N-A-B-I. So you can change the order however you want to. No problem. Perfecto. Next question. To increase the current sensitivity of a moving coil galvanometer, we should decrease. What should we decrease? Come on, think about it. To increase the current sensitivity of a galvanometer, what should we decrease? Strength of the magnet, torsional constant of the spring, number of turns in the coil, area of the coil. Wow, clear-cut confusion between B and C. Students are confused between B and C. I can see some of you are even saying A option. Be careful. I just gave you that formula. Theta is equal to NBA divided by your torsional constant or whatever you want to call it into current. Now, if you think about it, the sensitivity, if you want to increase it, then you want more deflection. What is the meaning of increasing the sensitivity? You want more deflection per unit current. So this theta by I should be more. So how can you do that? By increasing the turns, increasing the field, increasing the area, but decreasing the torsional constant. So the torsional constant should be decreased. Torsional constant should be decreased. So more sensitivity means more deflection for the same current. So theta by I should be more. That's what you should do. Perfecto. Now let me ask you a few more questions over here. Let's see if you can get this. Guys, imagine, let's see, let's do some questions on Biot-Savart's law also. Okay, let's say this is current I1. Let's say this is current I2. And if I ask you, there is a point P1 over here. What is the direction of the magnetic field? Assuming this is your x-axis, this is your y-axis, and towards you is z-axis. What is the direction of magnetic field? Positive x, negative x. Positive y, negative y. Positive z, negative z. Come on, let's see how many of you can do this. Is it z-axis minus z plus y plus x minus x? Both the currents are there. You are in the first quadrant. Let's see how many of you can get this, my warriors. Okay, plus z, is it? Let's see whether it is correct or wrong. First, use your right hand. Point your fingers on the right hand, because right direction, because the current is going there. See how your curled fingers are. They are going like this. So for sure, there is a field coming towards you. B1. B1 is coming towards you. Perfect. Very good. Look at I2. The current is going down. See how the curled fingers are. The curled fingers are coming like this, again towards you. So even B2 is towards you. Perfect. So hence the net field is plus z axis. Very good. I'm proud of you. Let's see whether you can do this question. Let's say you have a wire like this, and you are at this point P1. This is your x-axis, and this is how the current is flowing, I1. So what do you think is the direction of the magnetic field because of the current flowing in the wire? Come on, figure this out. Okay, Swati is saying 0. Okay, that is x-axis. This is your y-axis. Z is towards you. Figure this out. Okay, outwards, inwards, plus z, minus z, plus y, plus x, minus x. Figure this out. Okay, some of you are also saying 0. Again, some of you are saying z. Is it? Let's just find this out. First of all, remember one trick. Whenever you have a wire which carries current, if you are on the axis of the wire, the field due to that will be 0. The field due to that will be 0. So this wire and this wire have no contribution in the field. They have no contribution in the field. So basically ignore this and ignore this. The only thing which is there is this one. Hence, in this particular current, wire, and see the current is going like that. Curl your fingers like this. Thumb comes towards you. So the magnetic field is coming outwards in the z-axis. Perfecto. Perfecto. Excelente. Very good. Also, remember one small thing which many people forget. So if you have a wire which carries some current and it creates a magnetic field around it, remember this, the magnetic field is mu naught I by 2 pi r when you are outside, the wire. But when you are inside, it is mu naught I by this was fine. So mu naught I by 2 pi r square, and here you have small r. That is when you are inside of it. Okay, when you're inside of it. So please keep this in mind. This is very, very important. Sometimes they can even ask you graph-based questions. So when you're inside, it is directly proportional, and when you're outside, it is becoming inversely proportional to R. Please keep this in mind. Okay? Okay. Very good. Very good. Keep this in mind. All right. So why no contribution? The contribution is not there because the cross product becomes 0. So when you are on the axis, at this point, the R vector and the length vector L cross R becomes 0. That's why there is no contribution. Okay, let's take a small break. Before this, let me also tell you, those of you who are very confident of CBSE board examination and want to start preparing for the final leg of JEE, make sure that you join the crash course, which has amazing test series, assignments, and master teachers just like me for your final leg of preparation, because after the board examination, the JEE examination preparation should go in full swing. The first attempt is very likely to be in February end or even in March, much before your term 2 examination. So this will have 90 classes. Check out all the links which are there in the description box before we come back into the session after this short break. All right, so see you in 10 minutes. See you in 10 minutes. Okay, see you in just 10-20 minutes. Just give me some time. Okay, I'm just coming back. All right, let's take a break and return quickly. Hello guys, welcome back to the last leg of the session. Let's go ahead with EMI and AC. Those of you are joining in late, today is a problem solving session and high weightage, most important, very probable questions which can come in tomorrow's CBSE Board Term 1 examination of physics. So let's rock it, my dear warriors. And here comes the first few questions on EMI. Are you guys ready? Welcome back. So did anybody have anything? Or you're hungry? Yeah, still. Okay, so don't worry, it's going to be just half an hour more. All right, half an hour more, 45 minutes. That's it. We're going to get done with it. So let's get going. EMI, first question coming up on your screen now. There is a rectangular coil of 100 turns, size is this much. It is placed perpendicular to the field and the field drops from this much 0.1 Tesla to 0.05 Tesla in 0.05 seconds. The magnitude of the EMF induced inside the coil. The magnitude is asked. Hunger for marks, Vinith. That's the right hunger you should have. Perfecto. Then you will forget all the other kinds of hunger that you have. So I think we have to make use of Faraday's law. So according to Faraday's law, so EMF magnitude wise, okay, modulus is nothing but N into the change in the flux divided by the time it takes. So number of turns 100, change in the flux final minus initial divided by the time. Time is 0.05 seconds. What is flux? Flux is field into area. What is the field? Field before and after, if you compare it, it was 0.1 before and then it is becoming 0.05. The area is obviously the same. Okay, the area has never changed. So I can just take area outside and let's see what happens. So 100 and area goes out. 0.1 minus 0.05 into area. Area is 0.1 again into 0.05. This whole thing divided by 0.05. This and this gets cancelled. 0.1 minus 0.05 is again 0.05 again into 0.1. So 0.1, this 0 goes. So this will become 0.5. Do we have it? Yes, we have it. Check this out. Option A is correct. Perfecto. Excelente. Excelente. So let's get going to the next one. And don't worry guys, I'm going to tell you what you should do today evening and tomorrow morning as well, just before the exam. So stay tuned till the end, listen in, okay? So let's get moving to the next one. And those of you who join in a little bit late and you have missed the starting part of the class, you can always go back, replay the session that you have missed. Don't worry. What will be the self-inductance of a coil of 100 turns if the current 5 amperes produces a flux of 5 into 10 to the power minus 5 Weber? Many students will make a silly mistake. Thank you, Aditya. Can we have a night session, Harita? Yes, maybe someday. But tonight you need to sleep early. So I'm not going to have a night session with you guys. All right, what do we have? We want to find the what do we want to find? Find the self-inductance. All right. So is there a formula for self-inductance? Yes. How do I relate self-inductance with flux? Phi is equal to self-inductance into current. Is N in the answer number of turns? No. N is not there in the formula of phi is equal to Li. Be careful. A lot of students make this mistake. So flux is 5 into 10 to the power minus 5 is equal to L into current. What is the current? Current is just 5. So 5 goes. So L is 10 to the power minus 5. It has gone. So this is 10 into 10 to the power minus 6. So which is 10 micro Henry. That's it. It's not A, it's not C, it's not D. That's it. Okay. So this is useless information. This is just there to confuse the students. Many students multiply or divide by N. That is wrong. No, Shreya, that is wrong. That is the formula for L. L is having number of turns. L is nothing but mu naught, number of turns per unit length, into pi, okay, into pi r square into the length. This N has number of turns per unit length. This is N square actually. So N square is, N is capital N by L. Be careful. Okay, so L has that formula. 5 does not have such N term over there. If you have learned it, please erase it right now. That's why I put this question for you. 10 microhenry. Moving on to the next one. There is a square of certain side, x and y plane, and there is a field in that region given by this value, and B naught is some constant. What is the flux passing through that square? Come on, do this question. This is very easy. Visualize it. It will become even more simple. You have x, y, z axis. This is x, this is y, this is a z, and then you have placed that square in x, y, oops, not this one. You have placed it in x, y plane. That's what you have done. So think about it. Which field lines will actually cut through it? Only the field lines which are along z axis. So z component of the field will be responsible for that flux. So what is flux? Flux will be field multiplied by that area. So what is the field in the z axis? It is 4b naught. What is the area? It is L meters. So that's it. That many Webers is the unit. That's the answer. Very good. The answer is C. Okay, the answer is C. So understand this flux which is in x or y, it will not pierce through it. Only the flux which passes or cuts through that area should be counted. So that's why we have taken only the z component. Perfecto. Moving ahead to the next one. There are, okay, I think this was modified over here. 1 second. Yes. Okay. So there we have, yes. So there are two coils A and B as shown in the figure. A current starts flowing in B as shown. When A is moved towards B, the direction of the induced current in A is based on Lenz's law. Based on Lenz's law. Okay, come on, let's see how many of you can do this. Yep, L square was there and L square is needed. Yes, Nandana, L square, L into L, you will need it. L square, the area. Okay, come on, let's do this. There are two coils A and B shown in the figure. A starts moving and there is a current which is flowing in B as shown. When A is moved towards the B, then what is the direction of current? Think carefully what will happen. Because of this current, okay, because of this current, think there will be a field towards you. The magnetic field will come towards you. These field lines will go like this, go inside, cross. These field lines will go like this, go like that. They'll go like this, they'll go like this, they'll go, come from here and go like that. So the field lines will keep on coming out and going inside the plane. But as you come closer, there will be more field lines around it because there will be a stronger field around it. Correct? The field will become strong here. The field is weak here. So you are going from weaker to stronger field. If the field becomes stronger, then by Lenz's law, what should happen? It should be weakened. How do you weaken it? How do you weaken it? You produce induced current which will create induced field in the opposite direction. So a magnetic field should be created in this direction. So this is the induced magnetic field. Oh, sorry, my bad, dot. It should be created towards you because the field is basically inside from due to the external sources. So the induced field should be towards you. So if induced field is towards you, then what will happen? The current should flow in this direction. Use your right hand. The thumb is coming towards you. See how the curled fingers are rotating? It is curling like this, so anti-clockwise. So it should be anti-clockwise in nature. Yep, very good. That's it. Excellent. So this is based on Lenz's law. Got it? So what happens in Lenz's law is always see whether the flux is increasing or decreasing. Here, as this moves ahead, the flux which was inside is increasing because it is becoming stronger. Because the flux became stronger, you are going to weaken it. How you are going to weaken it? Again, so create an opposing flux. So where is the opposing flux going to be? Here. This will be your opposing flux. Opposing flux. How do you create opposing flux? Hold your thumb towards you. See how the fingers curl. The fingers curl this way. So this is the direction of the induced current. Always right hand thumb rule. That's it. I hope this is clear. Everybody understood this? Buranding, I hope you understood this. Okay, cool. Let's move on. Next question coming up on your screen. A square loop of certain side which is perpendicular to the field and its plane is now changed to a circle. The change occurs in t seconds. So the moment you change that square into a circle, there will be an EMF created. What is the induced EMF on an average? Very good. When it goes away, obviously it will be opposite. Okay, it will be opposite, bacha. So Vaishnavi NCERT exemplar, that is something which you should do in school or probably at home. Okay, that should be done already. All right, let's see how many of you can do this. A, B, D. Students are again confused. Make it unique, confused between A and C. Devrita saying A. Very interesting. So I'll tell you what you can do. First, it was a square loop. What was the side length? Side length is A. A. You convert it into a circle. Now the moment you convert it into circle, it has some radius. The length of that circle will be the perimeter of that square. Think about it. The length of the wire here was 4A. The length of the wire here is 2 pi r. Both these lengths are equal, right? So basically what will you get from here? 4A is equal to 2 pi r. So r will be 2A by pi. I think I will need it for solving the question. Let's start solving this. The change occurs in t seconds. So basically EMF, which is change in flux by time. Okay. So flux change is not happening because of field change. It is happening because of area change. So this will be nothing but B final. B is same, I think. Yeah. So area final minus B into area initial divided by the time. So B into A is flux. B into A is flux. Final flux minus initial flux. That's it. Now think B is common, final and initial. Okay. So just see what are the values of the area. What are the values of the area? The final area is a circle, right? So what is the area of the circle? Pi r square. What is the initial area? It is nothing but A square. But I can't leave the answers like this. I have to convert r into A. So check this out. B by T. This will become pi. R square means 4A square by pi square minus A square. Again A square will come common. So B A square divided by T. One of the 4 is here. One of the pi is here. Minus 1. So do I have it? Yes, I have it. If you are wondering why I did not put the minus sign, because I am only interested in the magnitude. Is that understood? Got it? Very good. So that's it. So the area change has to be calculated. The catch was to substitute the value of R in terms of A. If you do not put that value, then you will be confused. And the way we found out R was keeping the length of the coil constant. Be it a square, be it a circle, doesn't matter. That's what it is. Perfecto. Clearo. Moving ahead to the next question. Let's see whether we can get this. A conducting square loop of side length L, resistance R, moves in a plane with uniform velocity perpendicular to one of the sides. The field is constant in time and space, pointing perpendicularly inside into the plane of the figure. What is the induced current inside it? Students confused between C and D. Be careful. Between C and D. The correct answer is D, 0, because there is no change in flux. If you calculate the area, this area which is inside the flux is constant. So change is 0. So EMF is also 0. Perfecto. Let's see if you can understand what happens when it is just entering in. When it is coming inside, then what will happen? Because only a part of it is inside the flux or is contributing in the flux. Then what will the answer be? Will it be clockwise or anti-clockwise? Will it be clockwise or anti-clockwise? Come on, think about it. Then the flux, again you use this concept, the flux is increasing. Where is it increasing? Inside. The flux, as you go inside, more and more flux cuts through the loop. Then if the flux is increasing, you have to create opposing flux. So opposing opposing flux, where should it be? It should be towards you. If it is towards you, the current should be like this. This is the direction of the induced current. Induced current, if it is like this, the thumb will come towards you. So it will be anti-clockwise. Very good. Excellent. Moving to the next chapter, alternating current. Get ready. First question of AC coming up on your screen. When the voltage measuring device is connected to AC, the meter shows steady input voltage of 220 volts. This means, what does this mean? Come on, figure this out. What does this mean? When a voltage measuring device is connected to AC, means the meter shows steady input voltage. Even though it is measuring AC, it shows constant voltage. We know that in AC the voltage fluctuates, but somehow the meter shows constant voltage. What does that mean? Yes, correcto. The meter reads not V but V square, and it is calibrated to read the root mean square. Correct. So when it says 220 volts AC, this 220 volts is not the peak. What is it? RMS. So even in a varying voltage or current circuit, what it reads is the RMS value of that current or voltage. Correcto. Perfect. Yes. Moving ahead. In an AC circuit, current is given by this function. The time required for the current to achieve its peak value will be how much? What will be the time taken to achieve the peak value? This is a sine graph, current versus time. It is going to be like this. When do you think it will achieve its peak value? This is max value or peak value. What is this time going to be? Think, guys, I know in one cycle, for one cycle, the time taken is time period. So for going from here to here, that time taken, can you see it is 1/4 of the entire cycle? Is it not 1/4 of the entire time period? Correct? So what is the time period formula? The time period formula is 2 pi by omega. So this will become pi by 2 omega. So pi by 2, omega is over here. 200 pi is nothing but omega. So just put over here 200 pi. Pi by, so this will become 1 by 400. So hence you will get 1 by 400 seconds. Got it, my warriors? So the idea was this is 1/4. And use the time period formula. T is 2 pi by omega. Circular motion also, it has the same thing. Going ahead. Very good. Option B, correct. Very good, Shubham. Very good, clumsy man. Very good, Jaipalan. Very good, Ram. Very good, Sri. You guys are doing very well. Perfecto. Next question. The ratio of mean value over half cycle to RMS value of the AC is. Come on, guys. We are in the last leg of the class. More 10-15 minutes and we are done. Come on. Do this question. Figure this out. Many of you are saying A. Some of you are saying B also. Well, ratio of mean value to to RMS. Okay, this is half cycle we want. So this is half cycle. So for half cycle, okay, so you should know what is the average value or the mean value. The mean value is maximum value V0 times 2 divided by pi. This is the average value for half a cycle. Now whether it is full cycle or half cycle, the RMS is the same. RMS is always V0 by root 2. Doesn't matter half or full, because RMS may you square the values. So whatever is there below also comes on the top. So doesn't matter negative or positive half cycle. So basically you just divide them. So when you divide them, you are going to get the answer. So you can see V0 goes. So 2 by pi divided by 1 by root 2. So which is going to be 2 root 2 divided by pi. I think we have it. No, it is not A. It's not A. It's not D. Be careful. It is option C. It is option C. Be careful. Okay. Now, next thing. In a LCR circuit, which is AC, the voltage across each of the components is 50 volts. Across L, across C, and across R. What is the voltage across the LC combination going to be? Read the question and answer. What is the combination of LC going to give you? What is the voltage going to be? Prasanta, I will talk about it towards the end, bacha. Hold on. Okay, I'm going to tell you about it. I'm going to give you all the tips, what you should do, what you should not to before the exam, and how your mentality should be in the examination hall, everything. I'm just going to talk about it. Hold on. Okay, many of you are actually correct. Perfecto. Reason is phasor diagram. Remember, voltage across inductor is always on the top, voltage across capacitor is here, voltage across resistor is here. This is 50, this is also 50. So if you add both of these vectorially, they will essentially cancel out each other. If they cancel out each other, it should be 0 volts. Done, done. Very good. That's it. So if you guys are confused in AC chapter, please watch my Pathfinder or watch my yesterday's and day before yesterday's class, where I have discussed the formulas and I have also discussed important points from NCERT for every chapter. Yes, love is above all. Correcto. So all those students who have missed my classes, please watch my previous sessions. It will help you at least in the last few days. Resonant frequency is F. Inductance, resistance, capacitance is made 4 times of the initial values. Then the new resonant frequency will become how many times? Come on. Come on, figure this out. Figure this out. Think. Option D, option B. Khushi saying B, Jaipalan saying A, Shubham saying D, Gokul saying A. Wow, we have confused Janta. Guys, what's the formula for frequency of resonance? The frequency of resonance is 1 by 2 pi over LC. And here, okay, think of it this way. Resistance has no role to play, so forget about resistance. So capacitance became how many times? 4 times. Inductance became 4 times. But this is under the root. So root of 4 into 4 is just 4. That's in the denominator. So that means this frequency will become how many times? 1 by 4 times. So hence answer is D. Okay, inductance becomes 4 times. Capacitor becomes 4 times. 4 into 4, 16. Root of 16, 4. And that 4 is in the denominator. Moving ahead to the next question coming up on your screen. Here it is. The impedance in a circuit containing resistance of 1 ohm and inductance of 0.1 Henry in series for AC is of frequency 50 Hertz is how much? Come on, figure this out. What is the impedance going to be? What is the impedance going to be? Figure this out. Come on, my warriors. Think. Varsha, if the screen is blurred, that means you are watching the video in 360p or something. Please increase the resolution. On the right hand side, there is a setting, advanced setting. Click on it. Don't say higher speed. Just go with, higher quality, better quality. Just click on that. Come on, do this. The impedance of the circuit is asked. Many of you are saying C and many of you are also saying D. Confused. Well, I'll tell you what. Impedance is nothing but resistance square plus X square. Here there is only one inductor, so only one X will come. So resistance is how much? 1. So 1 square plus X is omega L. Now X is omega L, and remember omega is 2 pi F. So this will become 2 into pi into F. F is 50. So 50 into L. L is nothing but 0.1 and square. That's what it is. So this will become 1 square is 1 plus 0.1 and this 0 will go. Okay, so 2 5s are 10. So 10 pi square. So 10 pi square. Next step, what I'm going to do, 10 square is 100. Pi square is also 10. Why? I know this approximation. Pi square is roughly 10. 3.14 square is approximately G, which is 10. So when you do this math, think about it. 1 plus this big number, okay, this is also approximate. This is going to be approximately root of 100 into 10. Come on, 1 is very small in compared to 1000. So therefore, this will be 10 root of 10. Where is 10 root 10? Option B is correct. Many of you got it wrong. Be careful. Many of you made a mistake. Got it, my warriors? Understood? Perfect? Yeah. Let's get going. Option B. There you go. Option B. So it was all about approximations and how you calculate. And your mathematics calculation part should be strong, or else you will make silly mistakes and you will say D or C or something. Case study. the last case study for today's session, and then I'm going to give you all the tips and tricks. Stay tuned. Ready to take a screenshot? Here it is. Very interesting question. This is very difficult, let me tell you in advance, but we are going to solve this. Put up a heart once you have taken the screenshot. Just put up a heart once you have done with the screenshot, because you're going to need all the data for solving the question. Read it carefully. You cannot ignore it. There is a town which demands 800 kilowatt of electricity at 220 volts, and it's situated 15 kilometers away from the plant. It is generating 440 volts. Okay, the resistance of the two wires carrying the power is 0.5 ohm per kilometer. The town gets power through 4000 volts to 220 volt step down transformer substation. Very interesting. Let's start solving. So I'm just going to let me load it on my screen in the front, because I'm going to need that data. Hold on. Okay, just 1 second. I'm just going to load that values. Okay, I'm going to need it for solving the question. Okay, ठीक है, चलो, let's start solving. The first question is this. What is the value of the total resistance of the wire? What is the value of the total resistance of the wire? It's already mentioned. Okay, from the generation side to the town side. Okay, there will be wires. So the question is, what is the total resistance of the wire? Figure this out. It's not that difficult. Come on, think. The values were given. I think the values were given. The value of the resistance per kilometer was 0.5 ohm per kilometer. So if it was 0.5 ohm per kilometer, and the distance between the two towns was, check it out, was it 15? Yes, it was 15 kilometers. But remember, there are two wires. Do not forget that. So a lot of students make that mistake. So the answer will be 15 ohms. Oops, why are you saying C? Why are you saying D? D is correct. Yep, D is correct. C is not correct. Perfecto. B is definitely not true. 2 into 0.5 is 1, 15. That's it. That's the answer. Got it, my warriors? Perfecto. Moving to the next question. D option is correct. Next one. The line power loss in the form of heat, that voltage carrying wire, that distribution will have some power loss. The question is, what is that power loss going to be? That's the question. Figure this out. Okay, let me just tell you what is happening. There is a generation side. There will be, okay, let me just start drawing from here maybe. So you generate the electricity, and then you have your step up transformer, and then through these lines you transmit it, and then you have your step down transformer, and then you give it to the town, you can say. You can give it to your town. Okay. That's what the flow diagram is. So think, what is the power loss in the form of heat? Line. This is the line of transmission. This is the line in which it is getting transmitted. So what is the loss in that? In order to calculate the loss, what are you going to do? Think, okay, a lot of you are saying C. Think, what are you going to do? What are you going to calculate first? You need to know the current. Remember, power loss in the lines, the transmission line is dependent on I squared R. In case you have forgotten, let me remind you about it. So the power loss in that line, okay, power loss is basically I squared into R. R I just calculated. It was 15 ohms. Just now I calculated it. The only thing I do not know is the current. The only thing I do not know is current. So how do you calculate the current? Is the current given to you? Think about it. Is the current given to you? No, right? So I think we need to find this current out. How much current is flowing over here? For that, read the paragraph carefully. I'll just go to my paragraph. It is mentioned the town demands 800 kilowatts power and the line voltage is 4000 volts. So think about it. The line voltage over here is 4000 volts, correct? That's what is mentioned over there. And the power of the the power which the town is demanding is 800 kilowatts. It is demanding 800 kilowatts right over here. 800 kilowatts. So I know what is the power which is consumed by the town. I know that power will also be the same near the transformer. Even after the transformer, even before the transformer, it will be same. Do you guys agree with it? No, you can't use V square by R. You can't use V square by R because you do not know the voltage difference between these 2 points. What is the voltage difference between these 2 points? Do you know that? No. So you cannot do it. You just know this line over here has a step down transformer from 4000 volts to, I think, some 220 volts or something. Yes, 220 volts. This is 220 volts. This input power and output power both are 800 kilowatts. Now do you get it? Understood, my warriors? Okay. Now here is the thing. To find out this current, what am I going to do? Think about it. What am I going to do? Voltage and current and power. Just use 4000 volts into current will be that power, which is 800 kilowatts. So 800 into 10 to the power 3. So this 0, this 0, this 0, this 0, this 4 goes with this 2. So this current will be 2000 amperes. Interesting. 2000 amperes is flowing through it. So here I am going to put 2000 and square of that. So 2 square is 4 and this will be 10 to the power 6 into 15. 15 4s are 60 into 10 to the power 6. So I can just take few more zeros, I guess. 600 into 10 to the power. Have we made some mistake? Just check this out. 2000 out there. Oh, I think we made a mistake in the current. Yes, this 0. Yep, I'll just do this again. So power was I squared R. This R was nothing but 15. Yes, this was not 2000. I'll just erase this. Yep, this 0 and this 10 to the power 3 will cancel. This will become 10 to the power 2. So the current will become 10 to the power 2, which is nothing but 200 amperes. 200 amperes. So this will become 200 square. So 200 square. So 2 square is 4. 10 raised to 2 square is 10 to the power 4 into 15. So this will become 60 into 10 to the power 4, which is 600 into 10 to the power 3. So this is 600 kilowatt. I think now it's fine. Yep. Current was 200 amperes. So the idea over here is that it was given in the passage. That 800 kilowatt is demanded by the town. A transformer has negligible losses. So 800 kilowatt is also there in this line right over here. This point 800 kilowatts is fed inside the transformer. At what voltage? 4000 volts. So the input power of the transformer is VI, is nothing but the power. From that I got the current. Current is same. From current I found out the loss on that line. Is that understood? Is that clear? Okay. Shall we go to the next part of the question? I told you in before only, this question is going to be very tricky. Yes, it is 600 kilowatts. Perfecto. Now the question says, how much power must the plant supply assuming there is negligible power loss due to the leakage? Okay. So basically, this is the generation, this is the step up, this is your line, this is your step down, and this is your town. Now, in order to find out how much power the plant must supply, you must understand how much loss is there in this line. See, you might supply 100 laddus, but this line will eat away 20 laddus. Only 80 laddus will be remaining. So here the town gets, okay, at this point the town gets how much? I think there was 800 kilowatts. Yes, 800 kilowatts of power. The town gets 800 kilowatts of power, but in this line there was a loss. And how much loss was there? There was 600 kilowatt of loss from the previous question. We got this, correct? So how much will you supply? How much are you going to supply? Think about it. The supply power will be 600 plus 800, which is 1400 kilowatts. Is it there? Yes, it is there. Very good. Got it? Excellent. So the line lost 600, the town will get 800, so totally you will give 1400 kilowatts. Perfect answer. Next, the voltage drop in the power line is, so this is very different. See, a lot of students confuse over here. There is a step up transformer. This is your line. There is a step down transformer. This goes to the town. This comes from the generator. Understand, at this point you have it as 4000 volts. There is a current of 200 amperes. The question is not what is the voltage at that point. The question is what is the voltage drop across the line. This is what is asked. This is what is asked. Now what happens is, treat it like a resistor. If you treat it like a resistor, you will get the answer. Delta V is IR, current is 200, resistance, I think I calculated it. Remember sometime back you calculated the resistance. What was the resistance? Guys, what was the resistance? It was 15 ohms, right? Right? Remember that? So what will be the voltage drop? 2 into 5, 15, 30. So 3000 volts. Where is it? 3000 volts. It's right over here. Very good. Excellent. 3000 volts. Perfect. So 3000 volts drops here. That gives you 4000 volts. Perfect. Perfect. Option B is correct. Excellent. What is the voltage transmitted from the plant? Now what is this question? See, you generated the electricity, you stepped it up, you transmitted it, you stepped it down, gave it to the town. Near the transformer, here it was 4000 volts. We just calculated the drop to be 3000 volts. That means here what must be the voltage? Here what must be the voltage? This is the drop. The drop is 3000, then the remaining is 4000. Here it should be 4000 plus 3000, which is how much? 7000. 7000 volts. Correct. Correct. Very good. So what is the generator doing? The generator was generating electricity at 440 volts. It stepped it up to 7000 volts. It stepped it up till 7000 volts. In the line itself it dropped. By the time it reached here, it became 4000 volts. And then here it converted it back to 200 volts or 220 volts, whatever it was given. That's what has happened. This is the entire process. I think this problem has opened up your mind for sure. Please watch the replay later on also if you need any help. Yes, 7000 volts. Now, this is just the beginning. This is not the end, let me tell you. Because this was CBSE. Now you have to prepare for BITSAT, KVP1 and also JEE Mains and JEE Advanced. Every level is going to be more difficult than the next. But if you stay with me and like you would have realized, it will become easy. Things which are looking unachievable now will make it look so easy. And that's why you need the help via assignments, via test series, via regular classes. You cannot have haphazard classes. And if you are not at all happy with the current level of preparation, I would extremely, I would urge you to check out the crash course, because you know the crash course is a very well planned lecture series of 90 classes with assignments, with test series, full and part, and not just that, you get detailed analysis and you can compare your ranks with the previous ranks and you can see where you stand, and that helps you build motivation, because at the end of the day the competition is with you, not with others. If you don't improve, then you become stagnant, then you lose out on that. Not just that, there are going to be doubt solving sessions, there are going to be doubt solving mechanisms for you. You have any doubt from any topic, you can ask unlimited doubts in the class and even outside the class. And all of this for 9,000 rupees. You can get this offer only when you use the coupon code. So if you're watching this video right now, what you will see is right over here in the description box, you will see the JEE crash course. You can see it right over here. Click on this link. Once you click on this link, you will see the target JEE 2022 crash course. Who should join the crash course? Should a student who does not have much idea, should he join? Yes. What if you are satisfied with your coaching? Should you join? Yes. Reason, you will get to know new problems because you have been studying like a particular way for the last 1.5 years, 2 years. Now, if you see a different approach, you might open up your mind. You might start seeing new things. Arey, this is also possible. That is also possible. Acha, this test. Okay, this was there. Now I get it. So you'll start relating things. That's why 2 inputs is necessary. What you will get is your test series, analysis, assignments, notes in the form of PDF, live classes, recordings, doubt solving. Don't go for the light. Go for the classic because it's the same price. Go for the classic. Just click on this, buy complete course, use my coupon code. So the moment you use my coupon code, any problem happens, you can just get in touch with me and I can solve it. Okay, so that's the reason why I tell you. Plus you get the 10% off right over here. Just click on this, enter your details. So I'm looking forward to see you in the crash course because it's beginning this Monday. When is it starting? This Monday. There's also a crash course which has started last week. You can join that. You will get the recordings. It's up to you. The earlier you start, the better it is because you will complete it early. You will complete it early. So don't lose out on that precious time and don't come after 1 month, sir, now what to do? I'm giving you that opportunity. Grab that opportunity right now. The crash course is going to be in English. It's going to be in English. Yes, this entire crash course is going to be in English. So you should be very happy about it. It's an English crash course. Okay? Yep, you're going to get chapter-wise tests and assignments. That's what is going to be there. It's for 12th standard. Yes, entire 11th and 12th standard will be completed in 90 classes. Now, what you should do and not do today and tomorrow, let me tell you that. First of all, after this session, those students who have not attended my classes before, last 2 days, please watch that, not the complete one, only in parts. Don't waste 4 or 5 hours over there. Just watch the important things where you need help. Okay, there was assertion reason, there was case studies, there was formulas, there was NCERT underlined. Take help wherever needed. Number 2, make sure that you go through whatever, problems you can find today. Don't sit and read theory. A strict no-no for theory. Make sure you solve problems and problems only. From MTG, from Oswal, from Arihant. I think Arihant and Oswal, they have quite a decent set of questions. Exemplar, if you have not solved, solve exemplar. If you have not solved, the question bank which was provided at your school or by CBSE, please solve the sample papers out there. Next thing, if you have not been attending my classes before this, even on our platform on YouTube also there are so many lectures. If you just go to playlist, right, you can even search over here Shreyas Sir CBSE, Shreyas Sir CBSE. Just search for it. You will get so many classes out here everywhere. Okay, like for example this one, CBSE Term, most important case studies. Just click on this and in that description box you might find the PDF as well. Okay, right over here you can see session PDF. Click on this PDF. You will see all the case studies right over here. So many problem solving sessions I have been conducting over the past few weeks. So make sure you watch them. Yeah, mock test, exemplar or Arihant, you can do all the 3 things, but don't do it completely. Just do bits and pieces of that. I would say exemplar should be given high priority. Exemplar is very important. Okay. Yeah. Now, make sure you sleep early again and wake up on time. Make sure you reach the center well in advance. Tomorrow morning, don't open too many books and start studying. Just solve few problems if you want. Just maybe 3-4 questions here and there. Just revise few things. Just keep it for revision through your notes, through NCERT. That's it. Don't sit and solve 100 problems tomorrow morning. Okay? Don't do that. It will make you tensed. It will make you nervous. Don't do that. Not just that. Make sure don't believe any rumors. Lot of students will tell you, hey, the paper is leaked. How many of you have received such messages? Hey, the paper is leaked. hey, this is the paper, and then just solve the paper, tomorrow the job is done. Don't believe that. What if, most likely it is not the leaked paper, they fool you. And then they will tell, okay, this is the paper, that's it, you'll get full marks. Actually, that will be some random paper. They would have just formatted it. Maybe they will charge you some rupees, they will charge you some money just to extract money out of you. Don't fall for it. And then when you go to the examination hall, you find, oh, this is not even the paper. Then you are in a state of shock. So don't do that. Don't pay anywhere. Don't support and don't, in any way encourage any kind of cheating or any leaking. That's very, very important. These are rumors, correct? Only focus on your strength. You are going to crack the examination on your strength, not because of cheating, not because of some random thing which you are finding it on the internet. Just have faith, stay composed, make sure you eat well, and do not sleep late. Sleep on time. That's very important. So today, what you want to do? Practice more problems, revise through some theory concepts via my past classes if needed at max, and tomorrow morning few problems if you want, maybe here and there, 2-3 questions from each chapter, not more than that, and then mainly focus on revision through notes, NCERT or whatever you have. That's all. Okay, that's all you need to do. And tomorrow we are going to meet tomorrow at 2 o'clock. Okay, around 2 o'clock we are going to discuss the paper. If there are multiple sets, I'll try and discuss all the papers. Okay, so that's what I'm going to do with you, discussion, and then you can go ahead with chemistry. Yes, term 2 syllabus, I've already started light waves, so make sure you're regular in Pathfinder. Do you guys promise that you will be there? Because term 2 syllabus, JEE preparation, KVPI preparation, you're not going to leave it. Yes, make a promise that you are going to be there, and make sure in the examination you do not give more than 1 minute per question. You do not give more than 1 minute per question. Yep. If a question is difficult, leave it. You have options. Keep that in mind. Don't solve extra questions. Solve whatever you can. If there is a difficult question, go jump immediately to the easy one. I am telling you, the only way to manage time is jump. Jump strategy. Remember this jump strategy. Jump to easy one. Okay. That's it. Very good. We are going to crack term 1. We are going to crack term 2. We are going to crack KVPY. We are going to crack JEE examination. All of this on VNthuse with your favorite Capto Shreyas. All the best, my warriors. Do well, and thanks for liking. And yes, if you have anything to ask, please ask me on Shreyas_Vedantu. That's my Instagram handle right over there. Thank you very much. Take care. I'm going to have my lunch, and you too have